Okay, so we are going to talk about something called Hess's Law of Summation. So we just have talked about one thing that you're going to need to understand is that there's multiple ways to calculate heats of a reaction. There are three ways that we'll talk about to calculate the heat of a reaction. And then again, remember, heat can either be Q or enthalpy change. They are the same at constant pressure, which all these problems will be. One is to use specific heat or heat capacity or some other value like that, like we have done in previous videos where we have a specific heat, we have a mass, we have the number of degrees that the temperature is being changed, and then we can calculate the overall heat of that reaction. Another way that we're going to talk about in this video is called Hess's Law. And then the third way that we'll talk about later is called the enthalpy of formation. So all three of these are tools that we have to calculate heats of chemical reactions, and you will decide which of these methods you are going to use to solve the problem based on what you're being given. So we are going to talk about Hess's Law in this video. So what Hess's Law of Summation says, summation right there in the definition, sum, means that you can add known reactions together to try to determine the heat of an unknown reaction. Or for a reaction where the heat isn't known and you can't really complete that reaction in a lab because either the reaction is too slow or it's too extreme or something like that. So let me just show you an example of this. So say we want to know what is the enthalpy change for this reaction. So we want to know if we have 2 moles of carbon, graphite, so that's just a form of carbon, plus oxygen gas, and it produces 2 moles of carbon monoxide gas. We want to know what is the enthalpy change for this. Well, this reaction is difficult to measure. We can't measure this directly in a lab. So one way that we have, if we can't measure it in a lab using specific heat or heat capacity in a calorimeter, like we've already done, another way to determine the enthalpy change is to use Hess's Law of Summation for other reactions that we can add together to get this exact reaction, other known reactions. So we want to know what the enthalpy change is for this reaction. And we're going to do that using these known reactions. So this would have to be given to you. You wouldn't be figuring this out. So here are some other reactions that are known. Carbon graphite plus oxygen gas produces carbon dioxide gas, and that has an enthalpy change of negative 393.5 kilojoules. Another known reaction that we can use says 2 moles of carbon dioxide gas produces 2 moles of carbon monoxide gas plus 1 mole of oxygen gas. And that has an enthalpy change of negative 566.0 kilojoules. So now, what you're doing when you're doing a law with Hess's Law, what you're doing when you're doing a problem with Hess's Law, is you're going to try to manipulate these two equations. You're going to try to add them together somehow to make this reaction that you're interested in. whatever you do to the reactions, you also do to the enthalpy changes. So let me just show you an example of what this looks like. So we want to add these together, and this is kind of like balancing a chemical equation where everybody does it a little bit differently, and some people have some tips for where to start and what to do, but there's really going to be many different ways to reach the same answer. So if you see a way to do this differently than I'm doing, that is totally fine. I'm just doing what seems the most obvious to me, but there's lots of different ways to solve these problems. What I always do with these problems is I make sure that the reactants and the products are on the correct side. So I'm trying to make this reaction where carbon graphite is a reactant, oxygen is a reactant, and carbon monoxide is a product. Carbon dioxide is nowhere in this reaction, which means whatever happens here, I'm going to want these carbon dioxides to totally cancel out. So this is kind of like a puzzle where you're trying to figure out how am I going to add these two reactions together to get this reaction. So in order to add these two reactions, we want to multiply the first reaction by 2. Also notice I want 2 graphites. Here I just have 1. I'm going to multiply this whole reaction by 2. And when I do that, you also are going to multiply the enthalpy change by 2. So I'm just going to write this down here, and I'm going to write it in another color just so you can kind of track what I've done. So now I have 2 moles of carbon graphite plus 2 moles of oxygen gas produces 2 moles of carbon dioxide gas. And now my enthalpy change is 2 times this. It's going to be negative 787.0 kilojoules. So now that I've done this, I'm just going to get rid of this so I'm not confused when I'm adding things together. Now what I'm going to do is I'm going to add these 2 reactions together to get this reaction here. Because this 2 moles of graphite is going to be on my reactant side, I'm going to have 2 moles of oxygen, but one of those is going to be canceled by 1 mole of oxygen on the product side of the other reaction. And my 2 moles of carbon dioxide on the reactants in this problem are going to be canceled by the 2 moles of carbon dioxide in this reaction. When you add the reactions, you also add the enthalpy changes. So let me just show you how this works. So I'm going to add this to carbon graphite plus, again, 2 oxygens on this side, 1 oxygen on this side. Let's see, this oxygen is going to cancel out one of those oxygens. So now I have oxygen gas, and it produces these 2 carbon dioxides are canceled out by these 2 carbon dioxides, 2 moles of carbon monoxide gas. So I have manipulated these 2 known reactions to add them together to get my unknown reaction. When I do this, I also can add these enthalpy changes together. When I add negative 566 plus negative 787, I get about negative 1,353.0 kilojoules. So this is the enthalpy change for this reaction. Negative 1,353.0 kilojoules. That's the enthalpy change for this reaction that was unknown. So this is Hess's law of summation. The way this works is you're always going to be given a reaction that the enthalpy change is unknown for because it's hard to measure, because the reaction takes too long to happen in a lab. We can't use the specific heat or heat capacity to measure it. So what you'll do is you'll be given reactions where the enthalpy changes are known, and then you're going to add them together. So there are lots of practice worksheets for these. I would definitely recommend looking up some Hess's Law of Summation practice worksheets. A lot of them have the answers with them. Obviously, try to do it on your own, but then you can look back to make sure that you're doing it right if you get stuck. I am not going to give you anything that is too complicated on an exam. Let me give you one more example, and then I can always post some extra practice if you want. So let's do one more. Okay, so let's say, what is the enthalpy of the reaction of calcium metal with water? So this is the reaction that I want. I want to know calcium metal plus liquid water, and it produces calcium ions plus hydroxide ions plus hydrogen gas. And this is not balanced. I need a 2 here. Okay, so this is the reaction that you're given, and you don't know what the enthalpy change is. This reaction happens very slowly, so it's impractical to measure this delta H directly. However, we do know these other 2 reactions. So these are known reactions. And the known reactions are hydrogen ions plus hydroxide ions produce water. And that has an enthalpy change, delta H equals negative 55.9. And another known reaction says calcium metal, solid, plus 2 hydrogen ions produces calcium ions plus hydrogen gas. And that has an enthalpy change, delta H equals negative 543.0 kilojoules. So this is the information that you would be given, and you would be asked to solve for the enthalpy change of this unknown reaction. So now your job is to find a way to add these 2 reactions together to get this reaction that you want. So again, lots of different ways to do this. You do not have to do it the way that I do it. But what I always do to start is make sure that everything is on the correct side of the arrow. Then you can see how many of everything you need. Remember, if something is on the opposite side and you need to reverse it, reversing a thermochemical reaction causes the sign of that enthalpy change to switch from positive to negative or negative to positive. So look here, hydrogen ions are nowhere in this reaction. So I'm just going to write down some things that I know, maybe down here at the bottom. So hydrogen ions must cancel. So that's something I know I need to do. Hydroxide needs to be a product. So I'm just going to number these reactions just so we can refer to them as reaction 1 and reaction 2. So that means reaction number 1 must be reversed, because these hydroxides are on the incorrect side. Also, water needs to be a reactant. Which is the same. Reaction 1 must be reversed. Also, I need 2 moles of water and 2 moles of hydroxide. So 2 moles hydroxide, 2 moles water. That means I must need to multiply reaction 1 by 2. And when I do that, because now these are going to switch sides, these hydrogen ions are going to cancel, and that was the first thing I noticed. Again, none of this is necessary. This is just what I do to know where to start. So you're not just blindly moving things around with no reason. Okay. So I'm going to do this. I'm going to do it at the same time. I'm going to reverse reaction 1 and I'm going to multiply it by 2. So I'm going to take reaction 1, I'm going to reverse and multiply by 2. Remember, when you reverse it, you also have to change the sign. So that's what this looks like. Again, I'm going to write it down here so then we can get rid of that one. I'm going to reverse it, so it's and multiply by 2. 2H2O liquid produces 2 hydrogen ions plus 2 hydroxide ions. And the enthalpy change is going to have the opposite sign and multiplied by 2. So I'm going to write delta H equals positive. This positive sign is not needed. Anytime there's nothing there, it's implied that it's positive. But I'm putting it just so we are really sure that we've made that change. Now, let's see what happens when we add these two together. So I'm just going to get rid of this first line so I'm not confused about what I'm adding together. I'm going to have 2 water on my reactants. That's good. I'm going to have 1 calcium on my reactants. That's good. These 2 hydrogens that are reactants are going to cancel with these 2 hydrogens that are products. That's good. Calcium is a product. 2 hydroxide ions are a product. Hydrogen gas is a product. So we've done it. So now I'm just going to add it all together. Now I'm going to add these two numbers together. Negative 543 plus positive 118.8. You should get an enthalpy change of negative 431.2 kilojoules. So that's Hess's law of summation. You'll be given a reaction where we cannot calculate the enthalpy change easily. Then you'll be given some known reactions, and your job is to figure out how to manipulate the known reactions to produce that unknown reaction. And then whatever you did to the reactions, you also do to the enthalpy change, and that's how you can determine the enthalpy change of this reaction that is not easily measurable in the lab. There's lots of examples of these in your PowerPoint lecture. Also, you can look these up. There's lots of good examples online, or I can post some specifically. And there will be some good examples on your SmartWorks homework. Some of these get really, really complicated. I will not give you ones that are super complicated. You should be able to do these ones that I've done today easily. And there are some that have 3 equations that you would manipulate and add all 3 together. And we can work on ones like that if you would like more practice. But that is Hess's law of summation.